Hello everyone, this is part 2, a follow-up video for the previous active balancer versus passive balancer video. You might remember in the previous video, we had some unsatisfactory results. During charging with a passive balancer, the end result didn't seem to be balanced. And my assumption was, the charge current should be lower than the dissipated current through the bleeding resistor for the cells to be balanced. And when we were using an inductive active balancer, the charge and discharge result altogether wasn't satisfactory. And the assumption was that this inductive active balancer works for cell capacity lower than 60 amp hours. So in order to prove our theory, I prepared a smaller battery pack which has 3 2500 milliamp hour batteries, which sums up to 7.5 amp hour in total. The BMS is the same as the previous video, with one exception for the passive charge case, where I used a 3S BMS including the passive balancer feature. Please note that this BMS with passive balancing has a bleeding resistor of 43 ohms, which means that the dissipating current is 98 milliamperes. As a reference, I took a measurement of this battery pack using only the BMS. Before viewing the baseline result, I want to show you the capacity of each batteries used for this test. You can see that the battery cell number 1 has very low capacity compared to the others, even when these batteries were used in a parallel configuration before. And this is the result. You can see that cell 1, the blue line, is charging and discharging faster than the other cells, and it is limiting the overall capacity of the battery pack. Now, to test the passive balancing when charging, I used my LM2596 CCCV regulator module for limiting the charge current to 80 milliamperes, which is lower than the dissipating current of 98 milliamperes of the bleeding resistor. This is the result. For this test, I intentionally discharged cell 3 to introduce the imbalance between cells at the beginning stage. And as cell 1 is fully charged, the voltage doesn't increase further due to the dissipation in the passive balancer. And eventually, cell 2 and cell 3 reaches full charge voltage, and the balance is completed. This proves that our assumption is correct. Charge current should be lower than the discharge current through the bleeding resistor to achieve balancing for the passive balancer. This is the configuration used to test our second assumption that the inductive active balancer works for a capacity of less than 60 amp hours. Since we are using a battery pack of 7.5 amp hours, this condition is satisfied. And a normal BMS is used for this test purpose. This is the result. You can see that for both the charge and discharge case, the balancing has been achieved perfectly. This proves our second assumption, that the inductive active balancer works for lower than 60 amp hours. This is a summary of this video. The blue colored texts were just assumptions in the previous video, and it has been proven to be a fact throughout this follow-up video. Hope these videos on balancers helped you on finding your best balancing option. If you have any questions or suggestions, please leave a comment below. Thank you for watching. See you in the next video.